Thank you everyone for tuning into another episode of Coding Talks with myself Vishnaviji. Coding Talks will be available on all audio podcast platforms. Feel free to listen from any one of the podcast platforms as you prefer, depending upon your convenience. In addition to that, the podcast will be also available from today onwards on my YouTube channel. Recently, YouTube announced a feature where one can link the podcast to their channel, so that I done the same. And if you navigate to my YouTube channel and click on the podcast tab, all the past episodes will be available there, as well as the upcoming episodes. If you subscribe, you will get notifications. Today, I like to talk about one of the earlier services which I mainly worked on, especially for hosting web applications developed using ASP.NET MVC, Racer, Web APIs, background services. And this was back in 2015 when Azure was getting popular, and developers used to rely a lot on the classic cloud services. And recently Microsoft had an update, like they are going to retire the classic cloud services soon on the last date for migrating that to either some of the newer service models, or the classic cloud services extended model is the deadline date is something like August 2024, which is approaching and in the coming months. So there were different approaches. One is to migrate the application to a newer model like containers or serverless or app service, or maybe one can continue using the classic cloud services in extended support model. The problem with that is need to pay additional amount, and also the deployment model has to update to use the new ARM based deployment model in Azure. So if an organization don't want to do the heavy lifting of migrating the applications into a modern cloud native architecture, then they can continue with the classic cloud services in Azure, provided if they update the deployment model to use the new ARM template. But the main aim of this talk in this episode is to talk about the migration options, which we are going to discuss now. So when we want to migrate an application from the classic cloud services, why we want to do that? What is the problem or limitations with the classic cloud services? And what are the alternatives? What kind of services we can port the application into? It's not port, it's kind of a migrating the application. Classic cloud services, even though it's a cloud native one, but the main problem is that developer needs to do a lot of heavy lifting when they deploy and maintain the application. Deploy, maintain, or developing the applications using the classic cloud services. There were a lot of dependencies in terms of configuration files. And if you look into a classic cloud service model, the preferred approach for creating a new classic cloud service is that in Visual Studio, you first need to select the classic cloud service template, and then you need to provide which template you want, like whether you need an ASP.NET Web API or an MVC application or a background job. So this is like a kind of an additional burden you have to do, especially in terms of developing, and also while you're deploying that, you would need to consider a lot of factors, because the cloud services has heavy dependencies with the underlying Azure platform by itself. As a developer, we would need to spend some additional considerations while developing the application. And also, even though the service, classic cloud service, is still cloud native and it is scalable, it's not a cost effective one. So and it is getting depreciated in favorable of the newer services like container and serverless. Now, the debugging of the classic cloud services is also difficult. Like, it's not that much difficult, but kind of an additional consideration developer has to pay attention while debugging the application. They have to host an emulator in their local machine and then how to develop and debug. This is fine in the earlier days, but the recent modern development strategy is that the development has to be as linear as it is. The microservices model of deployment is getting popular. So the more linear the service, the more easier to develop and manage, especially in modular teams, and teams can own that without having any dependencies on the underlying cloud platform. That is the shift towards the serverless and containers, which are getting popular. Maybe because of that, Microsoft is also heavily investing in the newer models like containers and serverless, and they are going to depreciate the support for the classic cloud services. Still, the extended support is available, but they are recommending to move that into a newer model. And those organizations which still wants to keep the classic cloud services as it is, they can continue that with the extended service. Okay. So when we think about migrating this application, classic cloud services, into the newer forms, there are different choices. Like if you look into Azure, there are different services like app service is there, then containers, that's another one approach, serverless is another one approach. If you ask me which approach out of these one would select, then I will definitely say that if the development team or the organization has enough bandwidth to do the migration, then serverless would be the preferred choice. Especially because you would need to pay only for what you actually use. You can still achieve somewhat the same level in containers as well, but the benefit with the serverless is that it's kind of a model where you as a developer don't have to much bother about the underlying platforms. So you write the code, you deploy that, and all the aspects related to the scalability, maintenance, patching, and everything will be managed by the underlying cloud provider itself. So if an organization has an association with a cloud provider, whether it's an Azure or AWS, GCP or whatever, then selecting a preferred serverless service from them would be the modern approach, and it would be the best approach. And serverless can be considered in majority of the scenarios. The only exceptions is that in some cases where you are sure that you only have a fixed number of customers or usage for a particular month, then selecting a kind of a provisioned service will be more benefit than using a serverless scenario. And there are certain scenarios where a lot of dependencies you have with your application that you can only have within a VM or inside a containers. In that case also serverless may not be the preferred model. But there are certain other cases where majority of the applications we can have that in a serverless approach, provided you have enough time to develop that. There were certain considerations when we think about serverless. We have to shift the mindset in a different way, comparing with the traditional approaches of the app services or containers. Serverless works in a different way, where you are actually using the associated cloud services capability in a way, in an optimized way, so that you focus on the logic of the application rather than the underlying framework. So you are shifting the responsibility to the cloud provider in terms of maintenance, scalability. At peak load, the underlying cloud platform will automatically create instances of different serverless services, so you don't need to bother about that. And also all the associated logging mechanisms will be integrated with the serverless services itself. So everything, the heavy lifting of all the other parts of developing the application, like maintenance, scalability, and other things, will be handled by the cloud provider itself. That's one of the benefit. And the challenge for this developing this kind of serverless applications is that it needs a bit of thought, maybe a restructuring, re-architecting of the applications. How to be carefully do that, and it will take time and effort. Okay, then the other form of deployment is that containers, where you have your application, and this is especially suitable for applications where you think that your application has a certain set of dependencies which are not possible in a serverless environment. Then the containers will be a better choice there. And one of the highlight of containerized application is that you can ensure it will work same on your local system as well as on various cloud platforms, where you can also have multi-cloud concept in case of containerization, where you can host your containers either in Azure or AWS or GCP. It doesn't matter. You can have that in different places. You can have the different types of container services, starting from the, if you think about the Azure, it starts from the Azure Container Instances. Then after that, you can have a bit more higher capable services like Azure Container Apps. Azure Container Apps is based on the Kubernetes, but a kind of an customized by Azure. So it's not exactly similar to Kubernetes, but those of the cases where one don't want Kubernetes and wants a simpler model of Kubernetes, then Azure Container Apps will be suitable for that. Then the finally is the leading orchestration platform called the Kubernetes. Or leading orchestration service called the Kubernetes, where you can have everything. Kubernetes has its own features, like it can maintain lot of container instances by itself. It can self-heal by itself. It can have persistent storage, and the most of the cloud providers like Azure, AWS, GCP, they are providing the Kubernetes, managed Kubernetes versions, where you don't have to much bother about the underlying cluster management and all associated with Kubernetes. When I talked with different developers, one of the main challenges that face with Kubernetes is that if you are having a Kubernetes platform on premise, managing the clusters and the different set of machines would be challenging. So the concept of Kubernetes is that it's an orchestration platform where it can host and deploy a lot of containers. It can scale the container instances depending upon the configuration. So it's not about running on a single machine. It's about a cluster of machines, and managing that clusters and managing the Kubernetes on an on-premise would be challenging. Because of that, nowadays organizations are mostly relying on some of the managed Kubernetes services like In the case of Azure, it is like Azure Kubernetes Services, and in the case of AWS, it will be like the EKS, Elastic Kubernetes Services. So these are all managed versions provided by different cloud vendors. Similarly, for GCP also there is a version of Kubernetes available within them. In addition to this, there is a service which is similar to the Kubernetes. It can scale, it can manage the different instances, it can have the logging, storage, persistent storage, and everything related to that, which is much kind of a lighter service than the Kubernetes, and that is what we discussed earlier, like the Azure Container Apps services. And if you think somewhat more lighter services, you can think in terms of Azure Container Instances. If I'm going to talk about a lot about these services, it will take a lot of time. So we can specifically focus in this episode on migrating a classic cloud services into Azure Container Instances, because even though it's a kind of a simpler case study, still it can consider that for deploying to Azure Container Apps or Kubernetes as well. Because once you migrate an application to a containerized service, then definitely it can be hosted on the compatible platforms, whether it is an ACA or AKS as well. It doesn't matter. So the main focus on this episode is to focus on migrating a classic cloud service into the Azure Container Instances, and from there you can build your knowledge on top of that to deploy that onto other different managed services in cloud, like EKS, ACA, and so on. We will also discuss some of the difference you can see after we discuss the migration part. So when it comes to migration, the initial part is to think about the migration, whether the organization has enough bandwidth to do the migration, because it's an activity which involves architecting the applications, re-architecting the applications, splitting the multiple jobs hosted on cloud services into different modular services, more modular jobs. So it will take time. So if have enough bandwidth to do the migration, then can consider go forward. And there is a migration assistant that can be installed within the Visual Studio. So if you look into the extensions in Visual Studio, and if you click into cloud, I don't exactly remember that application. If you search like migrating .NET SDK applications into .NET Core, then you will get that link from the MSDN, Microsoft Websites itself, which can be, it's a tool which is provided by Microsoft, which can be used to convert your existing applications which were developed using the older versions of SDK, .NET SDK, to a newer version like the .NET Core 6 or 8 or whatever in the future as well. You can use that migration assistant to do that. So when you do the migration, it will analyze and show how you can migrate, and it can be used to create the migrated application. So that is one approach. Another approach is to do manual migration. That is also possible, but that will take some time. So depending upon your convenience, so either one approach is to use this application. Let me check the exact name of that application, and I will update you. 1 second. Yeah, okay. I will update that. Yeah. The the name of the application is .NET Upgrade Assistant, which you can find that from the Visual Studio. And if you click on the extensions within the tools part section of the Visual Studio, this can be installed, and then you can show the existing application, which will be your the .NET SDK based application, and then it will try to convert that, and it will analyze and show whether it can be converted or not, what all required changes needs to be made, and so on. But there are certain other cases where you have the classic cloud services, different jobs associated. Jobs means the background services associated with the classic cloud services. In that case, you can simply create a new version of .NET 8. Preferably the 6th, after the 6th, the 8th will be the current recommended version to choose, because it has support for a few more days. So you can create a new .NET. So one approach is to use the .NET Upgrade Assistant. Other approach is to create a fresh .NET Core application, preferably 8 in .NET 6 or 8. 8 is the recommended one, and then you have to include all the logic and the associated business logic and other parts from your existing SDK application, .NET SDK application, onto the newest one. So that is also another approach. For simpler applications, this is possible with minimal task, because when you do the migration upgrade assistant, you need to remove a lot of files, because like I said earlier, the existing classic cloud services has a lot of associated dependencies with the underlying Azure platform. So you would need to remove a lot of code. Whereas if you create a new .NET application, .NET Core application, then the application will be much leaner, and it has all the required codes. You would need to just add the business logic on top of that. Everything will be in place. And another part of the migration is to when you do a more cloud native application migration from classic cloud services, like I said earlier, the serverless will be the better choice, and below that the container can also be a possibility. Container migration is much easier, because you can simply add a Docker file to an application and you can easily containerize that. If you look into the cloud providers documentation for most of the container services, they highlight this as one of the benefit. That is, you can simply add a Docker file which includes all the dependencies for the application. We are not going to delve with too much details into the containerization part, because I already have an previous episode released last week. If you want to know about the benefits of containerization, you can check that, and how you can containerize an application, that also I mentioned there. Basically, it is just to use the existing Visual Studio simply to create a containerized application. In the Visual Studio Solution Explorer, you can right click and add a Docker file from there. With Visual Studio will automatically add all the dependencies, and it will create the file for you. Or you can also depend on the current the AI platforms like Bing Chat or Gemini or whatever. You can provide a prompt to the application that you need a Docker file for your current application, like whether it's an SDK or whatever. You need to mention that what language your application were written onto and what version it is, and then it will automatically create it will provide you the Docker file codes, and which you can add that as a file, and that will dockerize it. So once you dockerize that, you need to test that using either Docker or Podman. You can also run that from within the Visual Studio. So when I mentioned you create a new .NET Core application, and during that time, during the creation of the project itself, you can specify like that you need to you want to containerize it, and you need to simply turn on the enable Docker option, which will automatically add a Docker file for your application, and you can build the business logic on top of that. Now the splitting of the application, like I said earlier, the trend was that the earlier trend when cloud services were released is that developers used to include as many jobs there, because it's a kind of a managed provisioned service. So anyway, the organizations are paying a fixed amount to Azure. So the maximum amount of number of jobs it can include within that cloud service, the more profitable will be, or more optimizable in terms of code that application will be. Because of this reason, too many codes were included, especially if it was not a properly architected application. Then there were chances that it could include a lot of jobs managed using some form of a NuGet package called codes, which do the scheduling. So different services will be running there. So if you look into the cloud service, there are two main type of roles that the cloud service can run. One is it can host a web API, or it can host a website, and mainly that it uses an IaaS behind the scene to host that. And another one is the one is web role, and another one is the worker role, where in the worker role there won't be the IaaS won't be there, so it's run just like a kind of a background job. So that's the case with the classic cloud services. And because of that, your application, the earlier applications had a lot of multiple jobs included within a single service. So you would need to split each one of that from there, and ideally each one of those jobs would be a separate service by itself in terms of the modern architecture. So the more previously everything we were trying to embed everything onto one service, not embedding, including everything into one service. But now the modern trend is that independent deployability is one of the key factor in modern cloud native applications. So the more modular a service will be, the easier it to develop, as well as to test, maintain and deploy that application without affecting any of the other parts. So in that part, the concepts of microservices, modular architecture, and the concept of boundaries and everything comes into play, which I already discussed in most of the other episodes earlier related to microservices. The microservices architecture is not suitable for every type of application. So you have to analyze that whether microservice architecture is required or not. So if you quickly think whether your existing cloud service application should be ported to microservice or not, think in terms of the different boundaries or business domain associated with that application. And if you think that splitting that application into different modular services will make the application more modular or beneficial in terms of deployability or maintenance perspective or scalability perspective, then it would be better to move that to a microservice or modular architecture. For that, you would need to split each of these jobs into individual service. You can create separate services for that using the .NET Core. Add the required Docker files so that it can be containerized, and once that is done, then you can test that using the Visual Studio environment itself in your local environment. or you can use the GitHub code space as well, which is also another options which many of the organizations are nowadays trying it out. So once you containerize the application, you can run that application individually. If it is a simple service, then there is no need to ensure that every time to run it inside a Docker file within the inside a Docker within the Visual Studio. Once you tested that your Docker file and things are working fine, then the further testing can be done even without the Docker, provided if it is a simple service, you can run the project directly from Visual Studio. So now the difference you can see in terms of the maintainability and development easiness. Like in the previous classic cloud services, you would need the emulator in the first case, and also a lot of configuration files associated with that. When you migrate that, the service become much leaner, and also the configurations will be there within the app settings file, which is much easier to manage than having multiple CSFG file and package file associated with the cloud service. And also this service, when it becomes more modular with the included Docker file, this is kind of a containerized application which you can then push on to a registry. So registry is just kind of a repository. This is different from the code repository that which we use to host the source code for and change tracking of an application. This is somewhat related to storing the build associated with the Docker, or it's kind of a repository for the Docker images. So the difference you can see is here is that once you have a modular service with the required Docker file, you are building that using the docker build command, which will create a build which is immutable. Immutable in the sense that build have everything including your application, all the dependencies associated with the application, and you can deploy that onto any compatible container platforms, whether it is an ACI, AKS, or even in another cloud provider like AWS, EKS, or GCP, or whatever, or even on an on-premise system also you can host it. So when I mentioned first about the why we choosing containers, there are certain cases with the dependencies I mentioned, and there is another case where some organizations have a hybrid model where due to compliance reasons they need to host their applications on-premise as well as they need to run their application onto the cloud. So that means a same application will be running on-premise as well as on cloud. In that case, the container can be a best choose in that specific cases, because the containerized application can run anywhere, whether it is your laptop, on-premise, or container platforms. Anywhere it can run. It has all the dependencies associated with that. Now coming back to the topic again. So once you have that build, this can be pushed on to a container registry. Every cloud provider provides specific registry services as part of their offering. From Azure, the service is called Azure Container Registry. So the ideal way in an organization is to host your modular service code, including your Docker file onto a repository, and ideally you need to set up your build systems within the pipeline. So there are DevOps systems like Azure DevOps, or in AWS it's something called a code build, where you can create the build and deployment pipeline. So build pipeline, the main role is to compile your source code and make it as a build using the Docker file. So when we build for the container service, you need to build with the Docker file using the Docker runtime command. Docker command, and then you need to build that with the associated tools. You need to write a YAML for that, build YAML for that, and then you need to create a build pipelines in your DevOps system, whether it's Azure DevOps or Code Build or whatever you prefer. GitLab is also another one DevOps system. You need to create that, and then you need to, once the build is created, you can push that onto a container registry. In the case of Azure, it will be like a Azure Container Registry, and then you can have different repositories there within the Azure Container Registry, because when the containers is more relatable when it comes to microservices. So even if your application is a kind of a website, still it will be having multiple modular services. So that means each one will be having a separate repository in the container registry, which will store the associated build images. So now the immutable build image is there. The next step is to, using the DevOps pipeline, you need to deploy that onto the compatible container service service. So if you want to deploy that onto the Azure Container Instances, the Azure DevOps, I am mentioning in the case of Azure DevOps. In the case of Azure DevOps has a release pipeline where you can add different tasks, and using the CLI command you can invoke the Azure ACI, and you can create a new instance of Azure ACI and deploy your application, deploy your container built onto that ACI. Out of the different services, container services that are offered by the Azure, ACI is one of the lightweight service, where you can use that for running background jobs. You can use that for running on-demand jobs, where you need to run something scheduled on a specific time. You can use the ACI. For scheduling, you need the dependency of another one service in Azure, which is called the Azure Logic Apps. But if you want to run something immediately or run based on a trigger from another service in Azure, then ACI can be a better service for that. ACI, the mode of cost will be like, it's based on a consumption based plan, where you will be charged for the time it takes the container instances to run. Because of this, when you deploy an application to ACI or container instances, it must be developed in such a way that it should run and terminate after the application run is over. If you continuously run that, then the container instances will remain in a run state, and then you need to pay for that. I will explain that in terms of an actual use case, where, say for example, if you want to pull something from an external service and to update that onto your database, you can use ACI for that. You simply create a .NET Core service which fetch the data from an external service and update that onto your database, and then you will Dockerize it, adding a Docker file, then add a build pipeline. Using the build pipeline, you run the build pipeline and you create a build and you push that to container registry. So you need to write the YAML for that to build and push that to registry, and then from there the release pipelines can fetch the build from the registry, and it can push that to the required service, the required container instance services. Now the concept of environment variable is also important here, because the way of development is like, you build the image once and you will be running that on different environments like the integration environment, QA environment, or the actual production environment. You will be running that. So the build will be same. That means the configuration values, you should develop your application in such a way that it should read the configuration values from the environment settings. So the approach will be like during the release stage, the application will be reading the values from the environment specific. So that's one approach. There are different alternative approaches, like you can have a key vault and your application can read from there depending upon the value is you set as configuration. That is a different approach. But in case of simple way, the release pipeline can set the associated environment variables through the ACI parameters, and then it will, what it does is it will create that ACI instance and it will set the environment variables. You need to secure the environment variables using a secure flag, otherwise it will be stored in a plain text. Then after that, this environment variable and the way by which your application can read from the environment variable will make the container application runnable in different environments with a single immutable build. So the build image can't be tampered after that, and it can be used to deploy to multiple instances. Hope that is clear. More details about this will be available in the Azure Container Instance documentation. So the same will be applicable if you deploy this build image onto Kubernetes services like AKS or EKS or whatever, or even on-premise Kubernetes services. So this all same apply there. In that case, the Kubernetes platform will have the associated environment variables set through the config maps. So that means it can read the values from the environment variables and can apply, the application can apply it to there. Then the next important thing when it comes to containerized application is that these kind of applications are kind of a distributed applications where you have multiple services or multiple containers for a single application. That means it's the instances can be scattered, the services can be scattered and running on different containers. So logging is a critical part to troubleshoot the application. In the case of ACI, while you create an ACI instance using the release pipeline, there is a provision to set a log workspace so that it will automatically collect all the container logs, including your application logs, onto the Azure log workspace. From there, the Azure monitor can consolidate all the different logs from different systems. Whether you might be using, as part of your application, you might be using some sort of serverless functions, might be in some cases you might be using app services, especially for hosting web APIs or the websites or web APIs or whatever provisioned form of services you host. It would be normally in app services mainly. Then that's so different logs from different areas are consolidated, can be consolidated into a single area in the Azure monitor. There, the benefit of that is you can set events there, you can create different workflows based on the logs collected, and based on that, business decisions can be taken accordingly. So hope you understood an overall way of having the migrating the classic cloud services onto a modern architecture like the container services, and we discussed that with a case study of ACI. There are different other approaches as well. Then ACI is also a scalable one. That means when you run the ACI instances, it will be normally a single instance, but you can have multiple instances as well. one important consideration in case if you are planning to have multiple ACI instances is that you would need to create your application in such a way that it will not break even when it runs in multiple instances. So that's the responsibility of architecting. Due to this reason, when you port or migrate an existing classic cloud services into a newer model, even if you use the container model, still you have to be careful when you run the container instance in multiple instances, container images in multiple instances, because then your application will be running in multiple areas and you need to ensure that it will work without any break. And also you can integrate other services. Say in the case if you want to have some scheduled services which should run every day at a fixed time, to pull some data from an external service and update that onto the database, what you can do is you can create a .NET Core service, add a Docker file, then like I said earlier, create a build and deployment pipelines and make it available onto the container instance. So when you deploy that, it will run once, or maybe with the help of the configuration flags you can disable the initial run as well. Then the thing you can do is you can use either a simple logic app which can connect to this Azure container instance, or you can use an Azure function to trigger this container instances. So it will automatically run the service for you at that fixed time. There will be the charge, you will be charged for the logical app runtime as well as the container instances. Because of this, you should architect the logical app in such a way that it should just trigger the container instance and it should quit. Then the triggered Azure container instance will run, and once it runs successfully, then it will be terminated automatically. That means you won't be charged after that. So these are some of the overview that I like to discuss in today's session. ACI has more use. We just discussed about the case where we can host batch jobs, and other cases we used ACI for running burst jobs. Burst jobs means on-demand jobs. We also saw cases where we integrated the logic apps with ACI so that it can trigger the logic apps. There are certain other cases as well, like you can use the ACI as one of the node for your node means on link for your Azure Kubernetes. So that means it can trigger this ACI instances when you need some kind of a on-demand consumption nodes. You can integrate that there. Then you can, with the help of logic app, you can have complex workflows. While we discussed about updating some data from an external source and updating that onto a database, we discussed it as a simple workflow, which is an easier to understand workflow. But there are cases where we have a lot of different services and we need to have an orchestration which can be done with the help of a service like either the Azure function can be used for that, or simply you can use the Azure logic app for that purpose. Now if you want to deploy this containerized application onto something, a different service like an orchestrating services like AKS, you could do that. But for the normal deployment cases, orchestration may not recur in most of the cases, but in some cases, say for example, if you have 20 or more services, maybe 100 of container instances, and you want to run that, you would definitely need something like the Azure Kubernetes Services. Because Kubernetes is an orchestration platform developed by Google, and later they donated that to the Cloud Native Foundation, and from there after that the different cloud vendors have integrated that into a kind of a managed service. by choosing a Kubernetes service from a cloud platform like Azure or AWS, the benefit you are getting is it will be a managed service. So most of the underlying heavy lifting will be taken care of by the provider itself. The side effect is that you need to pay for the cluster management or the control node. You need to pay for that. Also, depending upon the number of instances you are going to run, you will also needs to be they will also charge accordingly. So based on how you want your application to run, you need to define that initially when you create the application in Azure Kubernetes Services. Mainly, if you look into plain deployment model, then the Kubernetes manifest file will be used for specifying what number of how many containers you want, and you will define how the scalable factors like how much minimum number, how much maximum number you need and all. Then you define all that in the manifest file, and you will let the Azure know about that manifest file, and it will create a container instance. So all the it will create a Kubernetes service behind the scene, as in the case of Kubernetes. So all the cluster management and all things will be taken care of by the that platform itself. That means if one of your service is running there and if it gets failed, then automatically a different instance of the service will be automatically triggered, created by the Kubernetes itself. So the orchestration or the heavy lifting of managing hundreds of containers will become the responsibility of the AKS or the Kubernetes platform, and you just focus on the specific container logic. Now, Kubernetes, when you use like this, the cost will be much higher. So in that case, you can go a further lesser weight service, something like it won't be having that much of a features as Kubernetes, but still you can have multiple instances, the clusters and everything, and that is called the Azure Container Apps, where you can have the multiple instances. And this is kind of a nearly serverless model where the Azure underlying platform will manage the container instances for you. So depending upon the configuration, whether it is based on the CPU or certain other factors, like you can have something like a configuration based on KDA, where you can specify like if the number of users goes this much high, then based on that you can trigger a certain number of instances. So all of those things can be done when you use the ACA, Azure Container App Service, and the AKS, Azure Kubernetes Services. So this is related, and this is mentioned in terms of the Azure, but for the other platforms it will be nearly similar. But for simple cases, the ACA would be enough. An ACA with a logic app or Azure functions will be an ideal combination. So definitely, even though the Kubernetes is much popular and many will be talking about Kubernetes, but for services less than 10, services less than 10 or 20 in number, then the alternative services like Azure Container Instances, along with other integrated services, or Azure Container Apps are also are a better option compared to the costly AKS one. So I think we have covered enough of the things to consider here, and now some of the key points you need to remember are when it comes to cloud service, we discussed about the concept of monolith, where everything will be in a single service. It's not exactly monolith, but still when you move that into a modern cloud native architecture, you can further split that cloud service into much simpler. Now when you split it into multiple services, then if your services wants to communicate with each other, you need to make sure that it will be communicating properly, and you have to also consider some of the factors related to the networking limitations. Like when everything is running inside a single cloud service, then maybe multiple jobs can interact with each other. But when you separate it and run it in different container instances, and those containers instances will be communicating each other through an HTTP or gRPC or whatever in some form of communication, you need to ensure that the communication happens correctly in the sense that in case if one service fails, then it should automatically recover when it is back in running stage. So maybe in some cases the synchronous form of communication may not be feasible. In that case, you would need to use some form of an asynchronous mechanism in between, something like a queue or something like a service bus in between, so that even though one service fails, it can pick it whenever it gets active again. So multiple services will be working, but even one of the failure in one of the service doesn't affect any of the other service. So there are advantages, there are cost benefit advantages, there are reliability advantages, but we need to consider the other factors like how these whole things works properly when you migrate an application. So thanks everyone, and we will be connecting with other episode soon, mainly related to some of these topics like containers or serverless. So thanks once again very much for listening and tuning into Coding Talks.